Hi, welcome to another video. In this video, we are going to solve Leetcode problem 238, that is product of array except itself. In this problem, they will give an array of numbers and we need to return an output array of the same size where each element at the answer index represents the product of the array except the element at that index. So consider this example where the given array is 1, 2, 3 and 4. This is the given array. So if we, what is the product of the array except 1, that is 2 into 3 into 4, that is 24. And at this point, we should exclude 2 from that product, that is 1, 3 and 4. So that is 12. And at this point, we should exclude 3 from the product, that is 1 into 2 into 4, that will be 8. And at this position, we should exclude 4 from the product, that is 1 into 2 into 3. So this is the process to find out the product. One way to do it is every time we can run through the array, uh, just skipping this index and finding the product and returning this, updating this answer array. And otherwise, there is one more approach where we can go through, that is, I think, O of n square time complexity. If we start going through array for each element, that means we will go through n times for n elements. That will be O of n square. So that will be the time complexity for that simple approach. But if we want to solve this problem using linear time complexity approach, what we can do here is we can view this product at any point as a left product and a right product. So left product represents product of all the elements which are present to left of this index, and the right product represents product of all the elements which are present to the right side of this element if you are considering this index. And if you are considering this index, left product represents product of all the elements to the left and right product represents product of all the elements to the right. So if you go by this approach, we can solve this problem just by O of n. We just have to go through array twice to compute the left product and right product at each point, and then we can compute this array by going through one more time. So that is the approach we are following. Let us declare an array of size products. We'll initialize it to 0. Length will be length of the nums array. So initially all the elements in the products will be 0. So before computing product, we need a left product. Left products. This array will also be of length nums, and there will be a right product. Right products array or list. We will initialize it to 0. So computing left products is easy. What is the left product? Product of all the elements which are present to the left. So for I in the range of len of nums, so initially what will be the product of, there is no element to the left of the product. So left products of 0 will be 0 because to the 0 index we have no elements to the left of the 0 index. So left products of 0 will be 0. So we will start from the 1. So what will be, let us declare a variable named product, initialize it to 1, and product will be equal to product multiplied by, so product multiplied by the previous value, that will be nums of I minus 1. So left product of I will be equal to product. I hope this makes sense. What we are trying to do here is at each index we are trying to calculate the product of all the elements to the left of that index. So similarly, if you want to compute the right product of last index will be 0 because to the right of last index there are no elements. So it will be 0. Then once again we can initialize product variable to 1 for I in range of len of nums minus 1, and we have to go till 0. So our product will be product multiplied by nums of I plus 1. So len of nums minus 2. Okay, nums of I plus 1. And then right product of I will be equal to product. So by this time we will have a right product and a left product. Let us try to print this left product and right product just to make sure we are not missing anything. I think this product variable is kind of redundant here. Let it be, but before optimizing, we'll try to print left product and right product. Whether let us make sure like whether we are getting proper put at this point, because these products are important to compute the product accept itself. You print right product and let us see what we are getting output. So initially I think it is going to run through 1, 2, and 3 and 4. Okay, instead of left products, I have done. Okay, let us see. At index 1, we don't have any left element, so we are getting 0. It is okay. At 2, we have only 1. The product will be 1. At 3, to the left, we have 2 and 1. Product is 2. It is fine. At 4, we have 3 elements to the left. That is 3, 2, and 1. We are getting 6. That is also fine. And let us check whether we are getting all the right product as right. So at 4, we don't have any right elements. We are getting 0. That is correct. And at 3, we have only one element, that is 4. Product is 4. At 2, we have to the right, we have 3 and 4. We are getting 12. That is correct. And at 1, we have 2, 3, and 4. We are getting 24. Okay, that makes sense. So I'm thinking instead of giving it as a 0, if we give it as 0, then to the right, if we are If you are trying to multiply these two numbers, we will get 0. So instead of 0, we can initialize it to 1, because since we are computing the product, if we were able to compute the sum or something like that, 0 makes sense. Okay, this time we are making it as 1 for the uh, that last element of the index. Now we have left product and right product. Then we can easily compute products array. So since we have left and right product, now answer will be just multiplying those two values. For I in the range of len of nums, products of I, left product of I multiplied by right product of I. I think we have, just by following this technique, we will get the product of the array except that element. Then we will return products. Let us see if this passes initial test cases. Okay, first two test cases are passing. And let us discuss about this time and memory complexity. So I think we are using three arrays. So for space complexity, I think it is better to write the complexity here. So what will be the space complexity? Space complexity, we are using around three arrays just for computing this product. So that will be 3 times n. So it is in turn implies, if we neglect the constant, our time complexity is O of n. And what is the time complexity? Time complexity will be equal to big O of, I think here we are going through array once and then twice and then thrice. So our time complexity is also O of 3 times n, which in turn reduces to, we don't write with if there is a time complexity of O of kn, it just means it is going to scale with n linearly. So time complexity will also be O of n with this solution. We have checked whether it passes the initial test cases. It is passing. And now we will try to check whether it passes all the test cases. Yes, as you can see here, it is passing all the test cases. Thanks for watching this video. If you are interested in learning more about data structures and algorithms, consider subscribing to this channel.